All right, hey everybody, this is 5.2, Graphing Basics. Okay, so again, I kind of have this kind of filled in, at least some of it already, just to kind of save time for the video. But you are welcome to pause or go to the filled in notes on Canvas. Okay, all right, so here is a basic quadratic, y equals x squared. One way you can graph is by making a table where you have x's and you can plug those into your equation. So any x you could plug into an equation and it will give you a y. And that's one way you could graph. So we could plug -1 into that and we would get sorry, why did I say 1? I meant -3. And you square that and that gives you 9. And then we could plug in -2 and that would give us 4. And you could plug in -1, square that, and then you get 1. So this is one way that you could graph. This one's fairly simple just because like lots of the problems you've seen before, like for B, usually have like 3 terms and things like that. But this one's kind of basic. And then I already have this graphed for the red. All right, so we can plot those as ordered pairs. So this is like -3, 9. We can plot that. And then we could plot -2, 4. And we've got that, okay? And again, that's a way to graph a quadratic. All right. Then in class, what we talked about was filling in the rest of these. Just to save you some time, you would plug those in just like whenever you have a value, plug it in for both of the x's. So -1 squared minus 4 times -1 plus 3. And then you can put that into your calculator and you'd end up getting 8. And then kind of repeat that process. One thing that was kind of, if you ever want to do this, sometimes it's easier to use your calculator to bring this back up and not have to retype the whole thing. And for like a TI, what you do is once you do all of this, you push enter, and then you can push second enter, and it will re-bring this, and then you can just delete the numbers inside and replace them with like 0 or 1 or 2. It'll kind of save you some time. Anyways, if you have questions on that, let me know. All right, so you go through that whole process, and those are the values you get. And then for C, same sort of thing, okay? And you could do this for any type of equation. If you're ever asked to graph something, you could always do it this way. It's not the fastest, but it always works. Okay, so I have all 3 of those graphed there. You might pause for a second and see if you notice anything about these 3 parabolas. All right, so the next thing that we asked you to do in class is, that kind of tells the story, but find the rate of change. Okay, so the rate of change is just how these values change as we go along. So what we're going to do for that is we will subtract them. So this is like 4 minus 9, and that gives you -5. And we keep doing that over and over. So 1 minus 4 is -3. 0 minus 1 would be -1. And then we'd have 1, 3, and 5. Okay, and this is kind of the thing that we're going to look at as we go along. Okay, so let's do the next one and see how those change. So if we did 3 minus 8, well, that's -5. 0 minus 3 is -3. -1 minus 0 is -1. 0 minus a -1 gives you a positive, so that gives you 1. And then we get 3 and 5. Okay, and we'll do the last one together. So we'd have -5, -3, -1, 1, 3, and then 5. Okay, so as you look at these, what do you notice about all of them? Well, it looks like the rate of change is the same for every single example. Okay, the rate of change goes from the center, we call like the vertex. Okay, I think from here you probably figure that out, is that this is like your vertex. That's your vertex, that's your vertex. Okay, and it's symmetric on both sides. So it goes up 1, up 3, up 5 on both sides. Okay, so that's like the rate of change, but does that work all the time? So we're going to go look at a few other examples. And just again, to save some time, if we do the rate of change between all of these, it looks like all of these are 2, 6, and 10. And then for this example, we have 3, 9, 15. So the rate of change isn't the same all the time, but what makes the difference? Okay, and I kind of have that highlighted already, is the leading coefficient. Here we'll call A. Okay, so for these first 3 examples, A is 1, and we get 1, 3, 5. For example D and E, A is 2. So everything is doubled from these first 3 examples. It was 1, 3, 5. Now it's 2, 6, 10. And then for F, A is 3, so it gets tripled. So instead of 1, 3, 5, it's 3, 9, 15. So that's basically the growth pattern of all quadratics, okay? The growth rate is always 1A, 3A, 5A. So if A is 1, it's 1, 3, 5. For example, just like 1A, B, and C. And if A is 2, then it gets doubled. We get 2, 6, 10. And if A is 3, it gets tripled, so 3, 9, 15. If A was 10, then it would be 10, 30, 50. You just multiply that growth pattern, that 1, 3, 5, by A. Okay, so the leading coefficient A determines the rate of change. All right, so let's go to the next page. It says, what do you need to find in order to graph? So to graph, we need to have the vertex. That's like your center point where we go from. From there, we'll use the growth pattern. We need to know what A is, though. So those are the 2 things that we need. We need the vertex, and then we need A, the leading coefficient. So maybe I'll write that here. Leading coefficient. All right, so if we can plot that vertex, here's the pattern. We'll always go from that vertex, from the vertex. We'll go over 1, and then we'll do whatever 1A is. Okay, if A is positive, we'll go up. If A is negative, we'll go down. Okay, so, and then we'd go over again, and then we'd do it again for the next one. So we'd do 3 times A. So if A is 1, then we'd go up 3. If A was negative 1, we'd go down 3. If A was 2, we'd go up 6. Okay? And that pattern can keep going forever, but usually our graphs won't be big enough to go to 7A. But it just keeps going. So 1A, 3A, 5A, 7A, 9A, 11A. Okay, so basically this is the same sort of thing, but visually, maybe you could think of it that way, is from that vertex, so here is our vertex, we always go over 1, and then we'll go up or down 1A, over 1 again, and then up or down 3A, and then we'll go over 1 up or down 5A, okay? All right, let's just do some examples real quick. I actually want to get rid of all of those, okay? Actually, I'll leave that key feature thing in there, and you could use that if you'd like. All right, so we'll do 4 examples, and then we'll be set to go. So first off, I will be giving you the vertex. The next 2 lessons, we'll talk about how to find the vertex from the equation. But here, I'll give those for you. We'll start by plotting those. So that's the first thing you always need to do, is to plot the vertex. So there's that. Now we need to figure out what's the pattern for this quadratic. So here A is the leading coefficient. You don't see it here, but A is 1. So if we do 1 times A, well, that would just give you 1 times 1 is 1. And then we do 3 times A. Let me zoom that in for you. And 3 times 1 is 3. And then 5 times A would give us 5. So from that vertex, we'll go over 1 always, and then we'll go up 1 because our pattern is 1, 3, 5 here. So we'd go up 1, then over 1, up 3, over 1, up 5. So we just followed those 3 numbers. And then we'll do it to the opposite side because it's symmetric. And then connect your dots the best you can to make it look like a parabola. And you're good to go. Okay? So let's look at B. What is the vertex? Well, it's negative 1, 8. We'll start with that. And then we need to find our growth pattern. So here, A is your leading coefficient, negative 2. So 1A, 3A, 5A. If we plug negative 2 in to those, we would get 1 times negative 2 is negative 2. 3 times negative 2 is negative 6. And 5 times negative 2 would be negative 10. So now we'll find our other points. Again, we start at the vertex. We go over 1, and then we'll do whatever the pattern says. So we'll go down 2, and then we'll go over 1 again, but now negative 6, down 6. And then over 1 again, and down 10. But for this example, it doesn't fit in your graph, and that's okay. We don't need to plot it if it's out of the graph. So there, we're just done. We'll do it to the other side as well. Over 1, down 2, over 1, down 6. And then we'll connect our dots the best we can. You're welcome to estimate where the next point would be. Like this would be, here's 8, 9, 10, 11. So it would be over here if you feel like it helps you draw a good parabola. Okay? All right, 2 more examples. Ooh, here's our vertex, 5, negative 2. So we'll plot that. Okay, and then we need to find more points. So we'll use the growth pattern. So what's A here? Again, it's your leading coefficient. It's A. A is 3. So we'll do the same thing, 1A, 3A, 5A. 1 times 3 is 3. 3 times 3 is 9. And 5 times 3 is 15. So here we're going to go over 1, up 3, over 1, up 9. And we're out of the graph, so we're done. And we'll do it on the opposite side as well. So over 1, up 3, over 1, up 9. Do your very best to do a parabola. It's kind of tricky, but just take some practice. And you're good to go. All right, last one is, this one's a little different, so I want to make sure you get this one. What's A here? Well, again, it's your leading coefficient. So here A is negative 1/2, or if you prefer it, negative 0.5. Okay, so we'll still do 1A, 3A, 5A. So 1 times negative 1/2 or negative 0.5 would give us the exact same thing. So I'm just going to write it as a decimal. You can do fractions too. And then 3 times negative 1/2 would be negative 1.5. And then the next would be negative 2.5. So those are the decimals. I'll write down the fractions as well, just if you prefer one or the other. So this would be negative 1/2, negative 3/2, and negative 5/2. Okay? I kind of like the fractions because you kind of still see that pattern 1, 3, 5, but either way, they both are good. All right, so we'll plot that. That's 2. The vertex is 2, 3. So that's our vertex. Here we need to make sure that you understand that we have a whole we always go over a whole one. Okay, so we need to go from here all the way to here. You might see that we have like half, like grid lines, and we don't want to go over a half, we want to go over a whole one. And then from there we'll go down like negative 0.5. So here we would have a point, and then we'd go over again, but now we'll go down 1.5, so that would give us here. And then we'll go the opposite direction, so over a whole one, and then down a half, a whole one, down 1.5, over one, down 2.5. Okay. And the next would be, if we had room, we'd do 3.5, but that would be out of your graph. So then we'll connect those dots, both directions. Put those arrows showing that it keeps going forever. That looks kind of hairy, so we'll take those off. And there you go. Okay? So it's not much different if A is a half or negative 1/2. You're still just multiplying that by 1, 3, and 5. Just make sure you go all the way over 1, not just a half when you go over. Okay? If you want, this example I think goes for example B. So if you want to fill in those key features as extra example, that's great. If not, don't worry about it. We didn't do it in class. All right. If you have questions, let me know.